Alright class, this is Miss Jacoy. If you have not already, attempt this problem, number 5, on page 22 in your big packet. You could do it anywhere else though if you've lost your big packet. So go take a second or a couple of minutes to try this and then come back. Alright, so first, read the problem. How high will a ball rise straight up into the air if upon leaving your hand it is traveling at 14 meters per second? How long will the ball be in the air? So again, it's two questions. One is how high is it going to be, and then two is how long. So it is going to be a split problem. You're going to have to do two parts. Alright, now given these two parts, let's draw a picture. So we have a ball. It's going to go straight up. And what happens to balls after they go straight up? They're going to go straight back down. So the first half of the problem is only concerned with how high it goes. So we don't really care about it going up. Alright. The next one, how long it's in the air, we'll talk about the easy and hard ways to do that. Alright, so here's our drawing. Let's go with now the things we know. So it's initially traveling at 14 meters per second. How do I know that? One, it's in meters per second, which is a velocity. Also, it says it's traveling and you threw it. Alright, this is a free fall problem because nothing's touching it after we throw it. So we are going to work with the idea of acceleration due to gravity. So I'm going to show which way is positive. I'm going to have up be positive, down be negative. So we threw it up, so it is going at a positive velocity to start. Acceleration is at a negative 10 meters per second. That's negative because acceleration is pulling it down. Alright, this does require you to think about some things. Like, at the top here, what is our speed? Because we do need to know that. If we need to know how far it goes, we do know, let's going to call where we start 0. Do note this is one of the more difficult ones. It will be very similar to what's on your quiz tomorrow. We want to know how high did it go. We also want to know how long will the ball be in the air, but that's a problem for the next time. So let's think. At the top, when it gets as high as it can get, how fast is it going? Hopefully you thought, oh, right at that very, very top point, it's not moving at all. It's stopped. So given these points, again, forget about time for now. Given these points, how can we find it? Hopefully after looking at these, you're like, oh, wow. This equation right here, it looks like it would be really useful. Because this is the equation you're going to want to pick. So always look at your variables and figure out which equation best matches those. So you have b squared equals v naught plus 2ax minus x naught. We want to figure out this x. This x naught is going to go to 0, so I don't care. Our x final is 0, so don't get rid of it because we need a placeholder on that side. But do write that it is at 0. Our v naught is 14 squared plus 2 times a negative 10 times our x. So now we gotta solve. You will need to square 14, so get out your calculator. 14 times 14 is 196 plus 2 times a negative 10 gives us negative 20x. Subtract this 196 from both sides, so you're going to have 196 equals a negative 20x, and then divide by that negative 20 to get just x by itself. You keep going, you do that math, and you're going to get x equals 9.8. So your top position is 9.8, oop, and I forgot my units, 9.8 meters. So I'm going to add that to our graph, or our picture. This is how high it got, 9.8 meters. This will be important in a second. Alright, so let's go back, talk about the second part. How long will the ball be in the air? Well, this picture is still valid, except I care about how far it's gone this entire time. So I want to figure out how long it's in the air until it hits the ground again. So, things we gotta know. Well, we now do know how far it went. Its position up in the air is 9.8 meters. But wait, Mrs. Jacoy, its position at the end is on the ground again. Yeah. We'll talk about that. If you say, oh, it starts at this and then it ends up on the ground, it's gonna say it went nowhere, which is not the answer you'd like. Alright. Then we keep going. We know that's final velocity up at the top, because we don't know how fast it's going at the bottom, so we do know, we're going to just talk about this time, is also 0. We know it's initial because we were told. And we know the acceleration because that's gravity. But what we really want to know is how long did it take? That's our big question here. Alright, X0. So actually on this one, you pretty much have all the information. The hard part is picking which one will be best. There's a couple ways to think about this. What goes up must come down. So when you throw something, think about the total time that it takes to go up is going to be exactly the same as the total time it takes to go down. So if we figure how long it takes to go up, all we got to do is double that time. Another way to think about it is if it went up with 14 meters per second, at this very ending point, it's going to go down with a negative 14 meters per second. However, I like to split my problems in half and make assumptions about the top. I know it's going to fall just as fast as it got up there. That's what we know about gravity. It's consistent. So given these things, you can really use a lot of different equations for this. I personally think this is gonna be your easiest one. But that's your choice. You could pretty much use most. It's because we know at the top it's going 0 meters per second. When it started, it was going 14 meters per second. We know what the acceleration is, and we're trying to figure out time. So you're going to move, and that's a positive, excuse me. So you're going to move it over, and I was going too fast. It is going to be a negative meters per second is equal to negative 10 times time. Divide by that. You're going to cross this out. You're going to cross out this negative. You're going to get 14 over 10. Do this, do the math. You're going to get 1.4 seconds is equal to the time. However, remember, we only took half the time. So it takes 1.4 seconds to get up here. How far do you think it takes to get down? 1.4 seconds. So you're going to double it. So it's going to be 2.8 seconds is equal to the time of how long it's actually in the air. 1.4 to go up, 1.4 to come back down.